2.1, factorizations. Okay, the first problems that you have give two numbers, and you can't see it, huh? I'm sorry. I am so sorry.
Sounds like I can't see anything.
It's like better to see the back of heads, right? Okay, 2.1 factorizations. It has two numbers, and it asks you if the second number is a factor of the first number. So if it gave you like these two numbers here, is the second number 8 a factor of 24?
Yes.
Yeah, that's all you have to do. See if this is a factor of that number. You don't have to show any division or anything, okay? It's just asking you that question. How about if it says 64 and 16?
No.
Are you sure?
Wait. Say that's on my homework.
No, it's not on the homework. 16 times 4 is 64. Yes, it is. So be careful, make sure and check it out. Okay, the second part of your homework says to find all the factors. When it says all the factors of a number, that is including 1 and the number, okay? So every single factor. If you want to find all the factors of 28, okay, does 1 go into the number? Yes. Does 2? Yes. 3? 8, 9, 10. Remember, you add the digits to see if 3 will go into it. 10, 8, 3 won't go into 10, so 3 will not go into that. How about 4?
Yes.
It's 4 times 7, right? 5?
No.
6? No. 7?
Yes.
That was 4 times 7, right? Okay, now that we have the center right here, you can do 2 times what is 28?
14.
14, and 1 times. Looks like a rainbow. Sometimes there's just one number in the middle, like 36 is going to have a 6 in the middle because 6 times 6. Let's do that one. 36, 1 will go into it. 2? Yeah, it's even. 3? 4? 5? 6? 6 times 6, right? Okay, 4 times what? 4 times 9 is 36. 3 times 12. 2 times 18. And 1 times itself. Okay, so if it says all the factors, list all of them, not just part of them. That's not like prime factorization. Okay, if you need to list the first 10 multiples, you don't have to show all kinds of work to do this. If it says list the first 10 multiples of 2, you're just going to list them 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20.
Oh, snap. I multiplied everything like
You showed it all
1,
out?
2, 3. Yeah, buddy.
Okay, sorry you had to do all that work. Okay, the next part, determine whether a number is divisible by another number. Okay, if it's one that you have rules on, you don't have to show all the division or anything to do all that. Determine whether, let's say the number 24 is divisible by 6. Okay. You already know 6 times 4 is 24, right?
Yeah.
Okay, if it was a huge number and you had to do the rules on it, do you know the rule for 6? remember? The divisibility rule for 6 is that if it divides by 2 and it divides by 3, it will divide by 6. So if you check to see if it divides by 2, if it's even, see how it's even? And the rule for 3, the divisibility rule for 3 is where you add it. 4 plus 2 is 6. That divides by 3, so this divides by 3. So to determine it, you can do the divisibility rules, or you can do the division. So if you have a bigger number, like, let's do this number here. I guess some of you have to actually divide it. Here's one here. Determine whether 4, 2, 2, 4. Determine whether that's divisible by 3. Well, let's do 6. Determine whether that's divisible by 6. Is it divisible by 2?
Yes.
Yes. Is it divisible by 3?
Yes.
4, 8, 9, 10, 11, 12. So, yes, it's divisible by 6. See, that's easier than having to do all that division. Just do those 2 rules and you've got your divisible, you got your answer, whatever it's called. Okay? So those are fine with you guys? There's one that says it's determined if it's divisible by 25. That one, there's no specific rule. You'll actually have to divide it. You can think about quarters though. You know, that's pretty easy to divide. Okay, now let's determine whether numbers are prime, composite, or neither. First of all, what numbers will be neither prime or composite? 1 and 0. Right. So if it's 1 or 0, you're going to say neither. Okay, what's a prime number? Like, pick a number, tell me what a number that's prime. 3, 2, 5. The numbers that only divide by 1 and themselves. Okay, those are the primes. Composite, if you think of it like composite minerals, like a rock, a lot of times rocks, a prime mineral would be if it was like pure turquoise. See, it's only that number in 1. A composite, if you had a rock that had a whole bunch of, it had some turquoise, and it has some copper and some just junk, that's composite, just like a composite mineral. It's got lots of components in there. The same thing with numbers. Like the number 6, it's not just 1 in itself. That's 2 times 3, so that's a composite number. Okay? That's how, because sometimes people get it mixed up. If you have something like that to remember it by, the composite's when it's got more than just 1 in itself. Okay, prime factorization. Is this too fast for you guys?
No, ma'am.
No? Okay. Finding the prime factorization. You can either do it the tree way, where you divide it up and it keeps dividing like stems on a tree, branches. 24, you could either put 2 times 12, or you could have put 8 times 3, 4 times 6. You could have done lots of things. If you do it this way, the bad thing, the thing I don't like about the tree method is you have to keep remembering to bring things down. Every time you divide, you got to keep bringing stuff down. Or when you're done, you got to look up here to see if you missed any. Okay, so you can do it this way. And there's your answer. If you put that into exponential form, the 2's, you have 1, 2, 3 of them. and then 1, 3. There is I'm trying to keep this thing focused, but it keeps coming out of focus. I'm sorry, guys. Okay, there's another way to do prime factorization where you don't lose any of your factors. It's called continuous division, or if it's not, that's what I call it, okay? Divide by a prime always, okay? Don't put 4 or 8 or anything like that out here. 24 divided by 2, that's 12. Divide that by 2 is 6. Divide that by 2 is 3. When your top number won't divide anymore, well, if you divide by 3, you get 1, but when the top number is a prime, then you're done. There's your primes just like you did over here. You don't have to lose any of them somewhere. So let's do some more of those. Let's do a bigger number. Let's do like 484. 484. Start with the 2's. Will 2 divide into that? It will, right? 2 into 4s, 2 into 8, 2 into 4, 242. Will 2 divide into that?
Yes.
2 into 2 is 1, 2 into 4 is 2, 2 into 2 is 1. Okay, that won't divide by 2, 2, 3, 4. It won't divide by 3 or 5. Does anybody recognize that as 11 times 11? Yeah. 11's a prime. Let's go ahead and divide that by 11, which is 11. So that's a prime on top right there. So to write that in exponential form, you would put 2 to the second power, because there's 2 of them, times 11 to the second power, because there's 2 of those.
Is this how we're answering it?
Yeah. Well, actually, the book doesn't even do exponential, so you can leave it spread out if you'd like. If you want to write it skinnier, so you can fit it into the answer column, the margin, you can go ahead and write it like this to squeeze it together.
And that was largest to smallest?
Yes,
Okay.
yes. Let's do one like the number 1,000. Okay, let's divide that by 5 just to make it, throw it off instead of starting at 2. Let's divide this one by 5. Into 10 is 2, so that's 200, right? Now let's switch back. Let's divide by 2. You can divide in any order, okay? As long as there's a prime out here, a prime number. 2 into 200 is 100. What would you like to divide by now? 5? Into 10 is 2, so 5 times 20 is 100. Don't put 4 out here. Let's do 5. 5 into 20 is 4. And then divide that by 2 is 2. Now we always put them from small to large, so let's put our 2's first. 1, 2, 3. If you want to circle them, it might make it easier for you. And then how many 5's are there? 1, 2, 3. So you can do it like that, or if you'd like to leave it spread out, do all the small ones first, and then the large ones in order. And that's all of 2.1. So we'll turn the camera off, and it said it was overheating, so we need to